Okay, this is a video in scientific notation. I want you to consider the number that I have in front of you. It's a very large number. The first thing you might want to do to get an idea of what the value is to use commas every 3 places to get an idea of how big the number is. So you're looking at thousands, so ones, tens, hundreds rather, and then thousands, 10,000, 100,000s, sevens in the millions, nines in the 10 millions, 4 is in the 100 millions, 3 is in the billions, 2 is in the 10 billion, so 23 billion is money, $23 billion. The decimal point right now, although it's not written in the number, is at the end, the far right, which puts it here. So in order for you to put this number into your calculator, you're going to have to change the way that it's written. It will not fit the way that it is. Scientific notation is a method which allows you to change the way the number is written from this is called standard form into a number with a factor of 10. So I'm going to move the decimal point to a position where the number that I make is greater than 1 but less than 10. Move it 3 places to the left, I still have a very big number. 6 places, 9 places. If I stop there, that would be 23.497. That doesn't fit the criteria. 1 more. If I move the decimal there, I would have 2.3497. If that's money, and you were asked to cough up that kind of money, or that's the amount of money that you won, of course, 23 billion is a lot of money. 2.34 is $2.35 approximately when you round. That's not equivalent. To change it to scientific, you have to count the number of times you've moved the decimal. Each time you move the decimal to the left, you're dividing by a factor of 10. We moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times. That means we divide it by 10 factors of 10. Therefore, you write it as times 10 to the power of 10. So 10 to the power of 10 would be billion times your 2.3, 10 billion actually. You would get the same number when you finish the question. So when you move the decimal to the left, as you did in this example, the number is going to get smaller the way that it's written, but you're going to have on the end of it times 10 to a certain power, which will make the number equivalent when you're finished. Let's take another example, a little bit smaller this time. So say you had a more reasonable number, 85,800, and you want to write that in scientific notation. It's not a huge number, but it still can go into scientific. The decimal point right now is at the end. If you're going to move it, you need to move it to a place where you make a number that's greater than 1, less than 10. So I'm going to move it here. And that's going to make the number equal to 8.58. Times 10 to the how many places depends on how often that you moved it. We moved it 1, 2, 3, 4 places. 4 places is 10 times 10 times 10 times 10, or 10,000. So 8.58 is going to give you 85,800 when you change to the other format. For example, if we had a number written in scientific, 3.614 by 10 to the 7th. This is scientific, and you want to change it back into regular format. What I recommend that you do is rewrite the number and then move the decimal. In this case, we're told to move it 7 places or 7 factors of 10. So we're going to go 1, 2, 3. Then we need to add a grand total of 7 places. I'm going to have to add 4 zeros to make it equivalent. You're not adding 7 zeros, you're moving the decimal 7 places to the right. So the answer would be 3614,0000, which would be the equivalent of 36,140,000. One more like that. Let's just say you were given a question, and it was 5 times 10 to the 6th. Your decimal right now is after the 5 to the right. Move the decimal then 6 places to the right, or in this case, you're just going to add 6 zeros. That's the equivalent of 5 million. So your answer would be 5 million in standard form. Those are all examples of numbers that are greater than 1. The scientific notation also applies to small numbers. You will see in this particular example, we have a number that's very, very small. If we're going to change this from standard form, which is written into, to scientific notation, we have to do the same thing, which is move the decimal to a position where the number that you make is greater than 1 but less than 10, which means I'm going to move it all the way over and change it into 3.2. Well, if that was money in the first example, 0.0000032, that's a very small amount. You can't just make the number into 3.2 and not change the value. So we have to then counterbalance the fact, multiply it by a grand total of 6 places, and write it as times 10. The opposite of multiplying is to divide, but scientific notation does not have a divide by 10 factor. It uses a negative exponent instead. So it becomes times 10 to the negative 6. 10 to the negative 6 is the same thing as saying 1, or saying basically dividing by 6 factors of 10, which is 1,000,000. On your calculator, if you take 3.2 and divide that by 1,000,000, you're going to get the same example that you had in the first place, 0.0000032. So whenever you have a small number like we had in this question, I mean a number that's very small, less than 1, your scientific notation answer will always have a negative exponent. All the previous examples had positive exponents. Another one, say you had 0.0009691. And you want to write that in scientific notation. Well, it's a small number. You move your decimal to such a position that the number that you make is greater than 1 but less than 10. You wouldn't move it there, that'd be 0.9. Wouldn't move it after the 96, that'd be too big, but in between the 9 and the 6, that's going to become 9.691, which is a bigger number. So your exponent's got to be smaller to counterbalance that. And that would be a grand total of 10, 100,000, 10,000, or 10 to the negative 4 in scientific notation. You should also be prepared to go backwards. If you're given a number like, say, 4.45 times 10 to the negative 9, you're going to say, wow, that's a small number. I've got to change that back into standard notation. So here's what you do. Write your number down a little farther to the right-hand side. 4.45, that's your original number. Now, 10 to the negative 9 means you need to divide your number by 9 factors of 10. That means 1, and then 2, 3, 4, 5, 6, 7, 8 more, or 8 zeros to hold the place in front of after your decimal. You double check, count them, so that's going to be after the 4, so 1, 2, 3, 4, 5, 6, 7, 8, I forgot a 0. I need to have 8 zeros, I only have 7, so there. I'll rewrite it. It should be 0.1, 2, 3, 4, 5, 6, 7, 8, and then 4, 4, 5. And those numbers have applications in a lot of areas of science. Masses of things that are very, very tiny, or voltages of things that are very, very small. There's lots of applications to needing scientific notation. There is a button on your calculator that will allow you to do this. On many calculators, it's either an EXP. Some calculators, if it's a Texas Instrument, it has an EE. Some calculators have it by times 10 to the power Y. And the way that you put them in there is you would type in, for example, 3.2, hit the EXP button. That does the times and the 10 for you pre-programmed. Then you would say hit -6. And that should give you the very top example on this page. You hit the equal sign, it should spit it back to you in standard form. Like so. 0.0000032. So, in conclusion, negative exponents indicate that the number is less than 1, very small. Positive exponents indicate that the number is greater than 1. It's all about counting and making sure when you put the decimal position, it makes a number that's greater than 1 but less than 10. Enjoy.